Hello everyone! In this video, we're going to look at the science behind Dalgona coffee. The coffee has become a worldwide phenomenon during the past few months of the COVID-19 pandemic lockdown. Question is, why is that so? This can be attributed to two reasons. First is due to the simplicity in making it, and second is due to the creamy, velvety foam it produced. As most of you probably have made it before, then you would know that it takes only these 4 ingredients to produce a cup of decent Dalgona coffee. And to make it, all you need to do is to whisk water, sugar, and instant coffee to produce a thick coffee foam that is then layered on top of a cup of iced milk. Is there any science concept involved in making this trendy coffee? Now, that's what we're trying to figure out in this video. First question would be, what causes coffee to form foam? And where does this foam comes from? You would notice that most coffee produce a kind of foam when it is first brewed, some with more foam and some with less amount of foam. So what happened here? The answer lies within the coffee bean. Imagine if I were to zoom in into the content of the coffee bean. Although it is a common knowledge that coffee is a good source of caffeine that you look for in an energy booster, it is also made up of protein, carbohydrate, and other volatile and non-volatile compounds. In the production of the instant coffee, the coffee beans have to be grounded first. During the grinding process, the cell wall of a coffee bean is destroyed, releasing all of its contents. Formation of the coffee foam is largely due to the interaction between some of the compounds, resulting in the structure known as the surfactant. A surfactant is made up of the hydrophobic tail, which is the part that heats and boils water, and the hydrophilic head, the part that loves interacting with water. The hydrophobic tails of the surfactant tend to interact with one another, forming a clump away from the surrounding water molecules. It is within this clump that an air bubble is trapped. Whisking the ingredients is the most important step in making Dalgona coffee. It is in this step that you can see the solution changes to become a stiff foam. So what happened here? The act of whisking introduces more bubbles in the coffee solution, thereby producing more and more clumps of air bubbles that are trapped within the surfactant complexes, forming what we see as foam. The uniform arrangement of surfactant molecules surrounding the air bubbles gives stability and stiffness to the foam produced in Dalgona coffee. Next, we want to figure out the role of sugar in the formation of this foam. Without sugar, your coffee would be bitter, of course. But does it help in the formation of the coffee foam? What happens when the sugar is removed from the ingredients? We produce 2 types of coffee foams as seen in this video. The coffee foam on the left is produced with sugar and the right without sugar. We let them stand for up to 20 minutes to see if there is any change to the foams and their texture. And here's the results. The one without sugar becomes watery and runny, whereas the one with sugar stays stiff. So what happened here? When the coffee is whisked, one of the content that is released is the oil. Oil is the enemy of the surfactant and has the tendency to remove the trapped bubbles. Absence of sugar causes the viscosity of the coffee drink to be low, and as water evaporates, it causes the surfactant to be exposed, and and come into close contact with these oil droplets. The contact causes destabilization of the surfactants and they collapse. Unlike the unsweetened coffee, presence of sugar in the coffee increases the viscosity of the drink and reduces the evaporation process. That way, the surfactant is exposed slowly to the air and the oil. Besides, sugar also possesses a crystalline structure that protects the surfactant from coming into contact with the oil. In other words, presence of sugar stabilizes the surfactant and causes the foam to stay firm. We hope this video helps you understand the science behind Dalgona coffee. Thank you for watching!